Alrighty, scientific notation. First question is, why the hell do we use it?
Makes things short.
Makes it a lot easier to say numbers. I mean, that first one, 1,480,765, is not that difficult. But when we get on to the next one, what are we talking? 36 trillion, 4 billion. Okay? The numbers get massive. When we're talking about, and there's an example, if you guys want, there is an example of scientific notation in here that I will do later on. Scientific notation and significant figures, because I'm only looking at scientific notation at the moment. But there is a massive number that we have to deal with later on, and it's the reason we use scientific notation. We also use it for very, very small numbers. Okay. So, the thing you've got to remember with scientific notation, it will look like this. In the end, it will look like this. Oh, that looks like a 0, doesn't it? I want it to look more like that. Okay? Scientific notation, every scientific notation number will end in times 10 to the power of something. Okay? Remember, what base do we use? In our normal number system, we use base 10. Cool? So if you times something by 10, it all moves up. If you divide it by 10, it all moves down. Make sense? And if you keep dividing by 10, the decimal point starts creeping up the line. Okay? That's what base 10 is. And we can use times 10 to the power of whatever to shorten the numbers that we're dealing with. Okay? So this is going to end up as something times 10 to the power of something. Okay? Now there is very specific rules on what that something is. Okay? They're very easy rules, but they're very specific. The number has to be greater than 1. Has to be greater than 1. I'll just call it n for number. And it has to be less than, delete that. Has to be less than 10. And it can actually be equal to 1. It can be 1.0. So it's going to be greater than or equal to 1, but it has to be less than 10. So the number 9.99999999999999999 works. And the number 0.000000000 does not, because it's not greater than 1, and that was a stupid number to give you. The number 1.0000000, or the number 1 works, but 0.999 does not. Does that make sense? Has to be between 1 and 10. Yeah? Okay. If you had the number 10.3, you could easily move that decimal point by dividing it by 10. Agree? So we'll look at that in a sec. But that's your basic rules. It will end in times 10 to the power of something, and that number here has to be between 10 and 1. Cool? Okay. So bearing that in mind, you're always going to have a number that looks like this. 1 point something, or 2 point something, or 3 point something, up to 9 point something. Does that make sense? But you're going to have something point something. Cool? So having a look at this number, you're going to have what point something? 1. Don't worry about anything else. You're going to have 1 point something. We'll worry about the something in a minute. But now you're halfway there. What's going to be at the end? To the power of something. We haven't worked that out yet either. Okay? But does that make sense? Just looking at that next one, what are you going to have? Point something. 3 point something. And at the end you're going to have times 10 to the power of something. Okay? What about this next one? What are you going to have? It's not hard. Do it the same way. What is it? A. Where's an 8? There's not even an 8 in there. What's your first number? Okay, you're going to have 3 point something times 10 to the power of something. What about this one? Jody? 8 point something times 10 to the power of something. Make sense? So I haven't looked at the answers yet. All I've done is get it set up. All I've done is take the first digit. Cool? Happy with that? Okay. Now, In every number, there is a decimal point. Where's the decimal point in this number? It's there. Where do we want it? Here. What do we have to do? Okay, how many spots have we moved it? 1, 2, 3, 4, 5, 6. We've moved it 6 spots.
That's what I said before.
Okay? And what do we have after the decimal point? And that's your answer. On this next one, what are you going to have after the decimal point? We're at the 3, that's where the decimal point's ending up. So what do we got after it? Do we need to put those other trailing zeros in? No. After the decimal point, we don't need them. They don't become.
Why didn't you just put 1 0?
Sorry?
Why did you put 1 0? Oh yeah.
Why did I put? Oh, because I'm an idiot. Thank you. That's better. Thank you. Okay. You happy with that? That's what was after the decimal point? Okay. Now the decimal point starts off there. How many points, how many spaces have we moved it? $13. And that's the answer to that one. Now, once again, as I said with the underlining in the, when you're doing the probability, if I see you putting these jumps on your exam, I will not be disappointed. Okay? It is a way of visualising exactly what you're doing. I was helping Kate with it yesterday, and when she said, "Are these right?" the first thing I did was do that, and I counted it. I don't try and do it in my head. I do it with my finger or with a pen to make sure that I'm not missing any. Okay? It is easy to miss them. Do it with a pen. No one's going to complain. All right, this next one. Where is the decimal point going to end up?
Yeah. At the end. Which made it very little.
Excellent. It's going to end up there. Cool. So what's going to be after the decimal point? 403. Everyone happy with that?
Yeah.
Now, how many spots have we moved the decimal point?
3.
1, 2,
Oh,
3.
minus
We've moved it 4 spots, but we've gone backwards, haven't we? Minus. When we went forwards, it was a positive. Now we've gone backwards, it's a minus. Does that make sense? Okay. Down here, where's the decimal going to end up? Cool. And this is literally how I do it. I write this on the paper. I put a decimal point in there. I do my 8 point and I go, okay. Write down everything I need. I know it's times 10 to the power of, and then I do my little bouncing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I put an arrow so I know which way I've gone. How many spots did I move? I went 10. So I went backwards. Does that make sense? Excellent.